Welcome to Biometrics and Beyond, identifying people without DNA. Today we're diving into the world of forensic science where DNA isn't the only game in town. Imagine identifying someone not through genetic material but by how they type, how they walk, or even by the shape of their ear. In this presentation, we'll explore the amazing field of biometrics, how we use unique physical and behavioral traits to tell people apart. These methods are especially valuable when DNA is unavailable or inconclusive. Get ready to discover the science that's helping solve crimes, secure buildings, and uncover identities using everything from fingerprints to foot shapes. What are biometrics? Biometrics are measurable physical or behavioral characteristics used to identify individuals. These include fingerprints, facial structure, the way you walk, or how your heart beats. They offer a way to verify identity without needing passwords, cards, or DNA. In forensic science, biometrics can link suspects to crime scenes or confirm identities. Unlike DNA, which requires lab testing, many biometric tools provide rapid, on-the-spot identification. Why use biometrics instead of DNA? Biometrics can be faster, easier, and less invasive than DNA testing. In cases where DNA is degraded or unavailable, other body-based clues still help solve crimes. Some biometric traits like fingerprints or iris patterns can be collected without needing body fluids. Law enforcement may use biometrics when time is critical or when DNA doesn't give a clear answer. These methods complement DNA but are powerful on their own. Fingerprints, the original biometric. Fingerprint analysis is one of the oldest and most trusted biometric methods. Each person has unique ridge patterns on their fingertips. Even identical twins don't share the same ones. Fingerprints left behind at crime scenes can be dusted, lifted, and matched to suspects. They're stored in massive databases that police can search within seconds. Because of their reliability, fingerprints are still used around the world to identify people in both criminal and civil cases. Palm prints and hand geometry. Palm prints work just like fingerprints, no two are alike. Crime scenes sometimes include partial or full palm prints, which can link a person to an object or surface. Hand geometry measures features like finger length, knuckle shape, and palm width. Though not as precise as fingerprints, hand geometry adds another layer of identity confirmation. These patterns are especially useful in access control systems and have forensic value in certain cases. Facial recognition technology. Facial recognition maps the shape of your face, eye distance, nose width, jawline, and more to create a unique digital signature. It can match a suspect's face to surveillance video or mugshots. This technology is fast and often used in security systems, airports, and police investigations. However, facial recognition can sometimes struggle with identical twins, disguises, or poor lighting. Still, it remains a powerful and growing tool in forensic identification. Iris and retina scan. The iris, the colored part of your eye, has patterns that are incredibly complex and unique to each person. Iris scanners take high-resolution images of these patterns to confirm identity. Retina scans, on the other hand, map blood vessels at the back of the eye. Both methods are difficult to fake and very reliable. Though not as commonly used in crime scenes, they're popular in high-security areas and identity verification systems. Voice recognition and speaker ID. Voice recognition identifies people based on how they speak, their pitch, tone, accent, and rhythm. Even if someone tries to disguise their voice, certain features remain consistent. In forensic science, speaker identification can link a suspect to threatening phone calls, ransom demands, or recordings. It requires audio analysis software and careful comparison. Voice prints, like fingerprints, are now part of forensic databases in some regions. Behavioral biometrics, how you move. Behavioral biometrics look at patterns in how people act, such as their posture, reaction time, or how they hold their device. One key example is gait recognition, analyzing how a person walks. Just like fingerprints, a person's walk is surprisingly distinctive. Surveillance footage and AI can match gait patterns to known individuals. Behavioral biometrics are useful when no physical traces are left behind, offering identity clues from afar. Ear shape and recognition. Ears are surprisingly unique. The shape, curves, and folds of each person's ear are as distinctive as a fingerprint. Forensic experts can analyze ear prints left on surfaces or compare ear shapes from photos or surveillance. This method is sometimes used in burglary cases when an intruder presses an ear to a door or window. While not as mainstream as fingerprints, ear biometrics can be surprisingly useful when combined with other evidence. Vein pattern recognition. Vein pattern recognition uses infrared light to see the pattern of veins beneath the skin, typically in the hand or finger. These patterns are unique and nearly impossible to replicate or alter. Unlike fingerprints, vein patterns are internal and can't be left behind at a scene, making them extremely secure. Forensic applications are still emerging, but some secure facilities use this method for access control. As technology improves, vein biometrics could play a larger role in personal identification. Keystroke dynamics, typing patterns as identification. Everyone types a little differently. How long they hold the keys, how fast they type, and the rhythm of their keystrokes. Keystroke dynamics analyzes these patterns to identify individuals using computers or phones. In cybercrime investigations, this can help pinpoint who accessed the system or sent threatening messages. It adds a behavioral layer of biometric authentication. Although subtle, This typing signature is surprisingly consistent and hard to fake. Signature recognition. Writing as a biometric. Your signature is more than just a scribble. It's a unique combination of motion, pressure, speed, and style. Signature recognition goes beyond simple shape matching by analyzing how the signature is made. In forensics, question document analysts use it to verify handwriting in fraud cases. While not as foolproof as fingerprints, it's useful for confirming or rejecting identity when documents are key. Digital signature pads now make dynamic signature analysis more accessible. Thermal imaging, heat signatures of the body. Every person gives off a slightly different heat signature, based on body shape, blood flow, and even health. Thermal cameras detect this invisible pattern, which can help identify people in total darkness or through smoke. It's used in rescue missions and military operations, but is gaining forensic interest. When combined with facial recognition, thermal profiles can help locate or confirm a person. Though less precise than other biometrics, it offers identification in unique conditions. Heart rhythms. ECG as a biometric. Each person's heartbeat has a slightly different rhythm and waveform. Electrocardiogram (ECG) devices can measure and record this electrical pattern. As a biometric, it's extremely difficult to copy, since it comes from deep inside the body. While still a developing field, heart-based ID is being explored for secure access systems. Forensically, it might one day help confirm who was using the device or present at a scene. It offers a hidden, high-security way to recognize someone. Body odor as a biometric. Believe it or not, your natural scent is unique. Your body odor is shaped by genetics, diet, health, and microbiome. Dogs have long used scent to track people, but now machines are learning to do the same. Biometric odor sensors can identify individuals based on their scent profile. It's still an emerging field, but shows promise for tracking people when other evidence is gone. In the future, scent might become a standard part of forensic investigations. Lip print analysis, the science of cheiloscopy. Just like fingerprints, the lines and grooves on your lips form a unique pattern. Lip print analysis, also known as cheiloscopy, studies these patterns to identify people. Lip prints can be found on cups, glasses, or even at crime scenes. Though not as common in the US, some countries have used lip print evidence in court. It's a lesser known but fascinating biometric method that continues to evolve. Retinal blood flow patterns. Retinal blood flow patterns are an emerging biometric method that analyzes the unique way blood moves through the tiny vessels in the retina. Unlike iris scanning, this method captures dynamic information that changes in real time, making it extremely hard to fake. Special imaging devices can map these patterns by detecting the movement of red blood cells under the surface of the eye. Because the pattern of flow is influenced by the structure of your unique blood vessels, it's nearly impossible to duplicate. Although still in experimental stages, this technique could become useful in high-security areas where ultra-accurate identification is needed. Multimodal biometrics, combining methods for better security. Multimodal biometrics combine two or more traits like fingerprint and voice to boost accuracy and security. If one method fails or is fooled, the other provides backup. This reduces false positives and is ideal in sensitive settings like airports or military zones. Though more complex and costly, the added protection often makes it worth it. These systems are also helpful in environments where one trait may be unreliable due to lighting, injury, or other factors. Biometric spoofing and security risks. Even high-tech biometric systems can be tricked. This is called spoofing. People can fake fingerprints with silicone or use photos to fool facial scanners. That's why systems now include anti-spoofing features like pulse detection or thermal imaging. As biometrics become widespread, developers must stay ahead of hackers with stronger defenses. Constant updates and innovation are essential to keep biometric security trustworthy. Concerns in biometrics. Biometrics raise major privacy concerns. Unlike passwords, your fingerprint and face can't be changed if stolen. If biometric data is hacked, it's compromised forever. People also worry about being watched or tracked without consent. Who owns your biometric data? Can you opt out? To protect users, new privacy laws and ethical standards are being developed. Balancing personal privacy with security is a big challenge in biometric tech. Data storage and encryption. How biometric data is stored matters. Most systems turn your fingerprint or face scan into encrypted code, often stored locally on your device or sometimes on secure servers. Local storage limits large-scale breaches, but any system needs strong protection. Never store biometric data in plain text. Using encryption and limiting who can access the data are key to keeping it safe. Biometrics in smartphones and consumer tech. Smartphones made biometrics mainstream. Face ID and fingerprint readers let you unlock devices quickly and securely. Some phones even recognize voice or gestures. Usually, your data is stored securely in a hardware zone called a Trusted Execution Environment, TEE. As tech grows, biometrics are showing up in smartwatches and home devices, but users should still set backup passwords and keep software updated. Biometrics in banking and payments. Banks are replacing PINs with biometrics like fingerprints and face scans. You may even use Voice ID over the phone. It's faster and adds security, but if stolen, biometric fraud is harder to undo. That's why banks combine biometrics with behavior tracking or multi-factor authentication. The goal is to make banking both secure and user-friendly. Biometrics in border control in airports. Airports use facial scans, fingerprints, and iris recognition to check IDs and speed up travel. These tools spot fake passports and reduce wait times. Some places are testing gates that board passengers using only a facial scan. It's efficient but also raises privacy concerns. Governments must balance traveler convenience with rights and data protection. Biometrics in healthcare. Biometrics help match patients to their medical records, avoiding mix-ups. Fingerprints or face scans also track staff in secure areas. In the future, heart rhythm scans might help monitor patients remotely, but health data is sensitive, so hospitals need strong privacy protections and must follow ethical rules when using biometric systems. Biometrics for workplace security. In the workplace, biometrics replace ID cards and time clocks. Fingerprints or face scans prevent buddy punching and restrict access to secure zones. Some use voice or hand geometry. While this boosts safety, it also raises concerns about constant monitoring. Employers must clearly explain what's being tracked and why. Used properly, it can increase security without invading privacy. Quiz time. Let's test what we've learned with some quick questions. What part of the lips is analyzed in cheloscopy? Answer: lip prints. What biometric uses blood vessels under the skin to confirm identity? Answer: vein pattern recognition. Which behavioral biometric analyzes how a person walks? Answer: gait recognition. What biometric involves measuring the heat your body gives off? Answer: thermal imaging. True or false? Your heartbeat can be used as a biometric. Answer: true. The ECG pattern is unique to each person. Thank you and see you next week. Bye.